All right, so what we're going to do now is we're going to do some manipulation of the ideal gas law. There are two major equations that come from this. PV is equal to nRT. The thing that's hidden in there, remember, is that N. That what you really got going on there is the grams per molecular weight. And so that's the number of moles. If you take the grams and divide it by the molecular weight, you'll get the moles. So you've got two different factors here, density and molecular weight. Right now what we're going to do is we're going to solve for density. So remember that density is the grams per volume. So if you take this equation and rearrange it, you get the grams per the volume, which is the density, and then that is going to be equal to the pressure times the molecular weight divided by RT. Now this would be a fine example of a non-calculator based question, even though it looks like you could do it calculator. If you got out your calculator and solve for the density of each of these guys, you could do it, but you can solve this guy without a calculator just by doing some basic comparisons here. So we're trying to figure out which one is the highest density. So the density is the pressure times the molar weight divided by R and T. So now when you go to compare these guys, remember that the R is constant, so it doesn't change. So that's really not a factor for comparison here. So you got the pressure times the molar weight divided by the temperature. Now the temperature looks like they are wildly inconsistent. You got 23, 35, and 13, but remember that temperature has to be in Kelvin. So in reality, that's something like 296, and that's something like 308, and that's something like 286, which, to be sure, are different, but really not very different. Because if you kind of rounded it, that's rounded to 300, and that's rounded to 300, and that's rounded to 300. So all of those temperatures are almost the same. So again, if you are without a calculator on this problem, temperature really isn't the issue here. So what we've really got here is the pressure times the molecular weight. So which of these guys has the biggest pressure times the molar weight? Well, here's your pressure, 2, and your molar weight, 28. So a rough guesstimate of that guy for X is about 56. So this guy here, pressure at a half at molar weight of 32, rough guesstimate about 16. And this guy here, a pressure of 4 times a molar weight of 131. Oh, okay. It's pretty obvious that it's that guy. Now, again, I don't know what that is off the top of my head. Call it about 130, so about 520, maybe about 524 without a calculator there. But it's pretty obvious that the xenon there is going to have the highest pressure at the molar weight when R is the same and the temperature really hasn't changed that much. So again, when you are comparing these guys, the temperature here really is right around 300 for both of them. Yes, it's a little bit different, but since it's just about the same for all of them, that temperature really isn't involved. So the xenon there, letter Z, should be